lesson 8 and 9 have the same title. It was a bit repetitive, which is why we decided to combine it. And the goal, which you can see on your papers printed, is to solve for a particular variable, like height, time, or length, when the equation would be more useful in that form. And we'll talk about what that means here in a second. All right, but you have this table printed on your paper. It shows the relationship between the base length and the area of some parallelograms. And they all have the same height. So you needed to complete the table and then answer the second question. So when you're completing the table, what are some strategies that we've talked about for how to best do that? Look at a table of values, and it says that there's a relationship between those two values. What are some things you could do to figure out what that relationship is? You look for a pattern. Could you guys find a pattern in what is given to you? What is the pattern? For at least the first 3 inputs, which the inputs for at least this part are going up by a consistent rate, then the outputs are going up by 3 each time, right? So that is a pattern. We could expect, like, if there was 4 in this table, what would the area probably be? 12, but then it's giving me 4.5. So what do you think is going to fill in this part if they're actually giving me 4.5? And 13.5, how do we get that? 4.5 by 3. Okay, so you found another pattern. Thinking like, what can I do to the input to get the output? And Kate said multiplying by 3. So doing 4.5 times 3 does give me 13.5. I was thinking more along the lines of like, well, if they would have added 3 to get 4, and this is 4.5, like half of 3 is 1.5. That's what I was thinking. But that's another good way too. All right. What about for 11 over 2? Personally, for me, I can't think that way with fractions, so I would probably make that a decimal. What is the decimal for 11 over 2? 5.5. In case you didn't know, you could just in your calculator do 11 division sign 2, if the fraction bar means divide, to get the let's call it decimal. So then what did you guys put for the area when the input is 5.5? Right, any disagreements at all? Okay, and then they now are not giving us the input, now they're giving us the output. So what do I do? If going from B to A, we were multiplying by 3, what can I do to do like the opposite? Divide by 3. So what is 36 divided by 3? All right. And then 46.5 divided by 3. 15.5. All right, I don't have my book in front of me yet, so I'll take your word for it unless someone else disagrees. All right, but yeah, look for a pattern. See if you can emulate that pattern. Even better, which might even be more helpful with some of these random numbers that they give you. See if you can make an equation to represent that pattern. So if you haven't decided already which equations could work, so it's this or this, and then this or this, then go ahead and decide that right now with your group. I'll give you like 60 seconds. So table 9, when given your two options for what B equals, what did you guys choose? Okay, so let's see. B is like this number, for example, right? So see if I plug in A here, if it works. So, or you could also plug in the B too, and then see if it's true. Is 3 divided by 3, 1? And then we can even try that one. Is 6 divided by 3, 2? So then I would pick that one as well. If I go the opposite way, 3 times A, which is also 3, is 9, not 1. So then don't pick that one. All right, now table 1, when you're given the option for what A equals, what did you guys choose? Do you remember? Okay, well, if you had to pick now, like if it was a test and you had to send something in. Maybe use the strategy that we did over here where we like plugged in the B's and the A's to see which one gives me something that's true. You have a 50-50 chance. Two options, A equals 3B or A equals B over 3. Okay, so let's see if that's true. So if I plug in like my first set, it should really work for this whole table. But if I plug in my first set of values, A is 3, B is 1, is 3 times 1, 3. Okay, let's see if it works. When it's 1, I usually like to keep checking because you know those identity properties. But I'll keep checking, like if I plug in the second set, 6 is my A, 2 is my B, is 3 times 2, 6. So it works. All right, when you have multiple choice options and you have a table, you could do that. Or you could try making it from scratch and think like, what math did I have to do? All right, remember we were multiplying by B over here. So 3B is what we were doing each time. 3 was staying constant. What we were multiplying it by was varying. All right, and same thing over here. The square inches were varying, which is why we gave it a variable. That's my area. And then what was staying constant though was dividing it by 3. All right, so that's been helping me do the practice as well when you guys ask me questions, is I try to see what math I had to do to fill in the table. So any questions on the warm-up? All right, so 2 equations represent this, but in each equation, one variable is alone. All right, so really kind of keep that in mind when we move on to the next one. So post-parade cleanup, it's also on your paper if you want to follow along. After a parade, a group of volunteers is helping to pick up the trash along a 2-mile stretch of road. The group decides to divide the length of the road so that each volunteer is responsible for cleaning up equal length sections. Find the length of a road section for each volunteer if there are the following numbers of volunteers. Be prepared to explain your reasoning. So do that. And then if you can figure out what the equation is, then even better. So just 1 and 2 for right now. Think of all those strategies I gave you before. Consider making a table. Consider making the equation right off the bat if you can figure out what math you're doing. But 1 and 2 in your groups for right now, I'll give you like 2 minutes. 5. Anyone get something different than that? Okay, I think some people are seeing some mistakes maybe. I haven't even said if it's right yet. So let's see. Can you walk me through your thought process, Nathaniel?
Well, the amount of miles that each person gets is pretty much just 2 divided by the amount of people.
Okay, so there's 2 miles total, 8 people, and we want them each to have like an equal amount of sections. When you put that into your calculator, 2 divided by 8, it reads either 1/4 or 0.25. It'll probably read as 0.25, but sometimes your calculator could be in fraction mode, and same answer anyway. 0.25 miles each or 1/4 is your fraction. Everyone see what we're doing now? Okay, so the rest should be, even if you didn't get it in the 3 minutes, the rest should be something you can do on your calculator. So then table 2, can you give me the next one when there's 10 volunteers? 0.2 miles. Anyone know the equivalent fraction to that? By the way. 1/5, but. Because yeah, it's 2 now divided by 10, which if you simplify either by hand, or you could also simplify on the calculator, it will become 1/5. So yes. Now 25 volunteers, table 3. All right, table 3, we'll come back to you for that one. Make sure you figure it out right now. Table 4, what about for 36 volunteers? Table 3, did we find our answer? Do we know what math we're supposed to do, class? Yeah. Really similar to the first 2. What's the only thing that's going to change now? Which goes where in the fraction? Okay. For 25 volunteers? Would it make sense that if I have 8 volunteers, is that, 0.125? Okay. Class, did we get something different than that? $1.25? Not. Well, think about that, like, would that answer make sense? If I have 2 miles total, should each of my 25 volunteers do a mile, more than a mile? Okay, we'll put that in the calculator right now. For table 4 though, do you have something for 36 volunteers? 0.5 repeating. Okay, so let's see. In each situation, so A, B, C, and D, the only thing that is changing is what? Is the miles changing, like that they have to clean up? No, the 2 miles is still going to be there. But what's changing each time? The amount of volunteers, which in the first 2, we noticed that we have to divide that to see how much each should clean, right? Like if I had cookies and I needed to like divide it between all of you guys, or like the pizza party, remember when we planned that?
You would divide your total by however many people there are. I need Desmo, so that's what I'm pulling up. So, because I can't do this math in my head, you shouldn't do it either. But the math that you should be doing is 2 divided by however many volunteers there are. So when there's 25, it should be 0.08. Oops, I didn't mean to erase all of that. And then when it's 36, so 2 division sign or the slash also gives you the fraction bar. It's not 0.5 repeating, it's 0.05 repeating. So that makes a difference. Anyway, because would you rather have like a nickel or 50 cents? Yeah, so like, yeah, it's 0.05 repeating. Anyway, so let's put that on our papers if we didn't already have that and how to do it in case we forget later when we look at our notes. So for 25, it was 0.08. And for 36, it was 0.056. I'll round it. Or you could put 0.05 with the line over the 5 to show that it's repeating. Questions on that process? All right, then for number 2, you're going to now, and we'll do this right now, like we're not gonna give time. We're gonna write an equation that would make it easy to find L, the length, which is what we already solved. Of the road section in miles for each volunteer if there are n volunteers. Now, when there's problems on your practice and even on your quiz, when they say that makes it easy to find, that means I don't want to have to do like a whole bunch of steps to get the answer. I want to be able to just type it in my calculator and move on with my life. So in each situation, do you think like that was really hard things to put in our calculator, or do you think it was already easy to find? So in that case, think about what was staying constant the entire time. What was staying constant? So I'm going to leave that as 2 because the miles were not changing. I'm not going to put a variable for that. But in each situation, what was changing? And each time we did 2 divided by the number of volunteers. And I'll use their variables. They want you to use n. They said n for volunteers. And did that alone give me my length? Yep, it gave me the length that each person needed to now choose. So this is what they mean by that. That would be the only right answer, although technically you could do n equals, or maybe that's like the next step. So maybe I won't take that away. But when it says makes it easy to find L, it wants that variable alone on one side. Okay. So now look at number 3 on your paper. Find the number of volunteers in the group if each volunteer cleans up a section of the following lengths. So now you know what they're cleaning up, but you don't know how many volunteers there are. So now figure that out. And then what you will be doing is making an equation that would be easy to find n versus L. Questions on that? Okay, so 3 more minutes to finish these 3 parts. Volunteer is cleaning 0.4 miles. How many volunteers must there be? Yes. Let them think it through.
Table 5, I'll come back to you, but that's the one you guys have, 0.4 miles. Table 6, do you know how many volunteers there are if they're each cleaning up 2/7 of a mile? .28 and then what? Okay. So think about this. When you are, and this is a great test strategy. If the problem is asking you to find the number of volunteers, is it possible to have 0.28 of a person? No. So odds are that's probably not going to be it. Can someone help us out for B, 2/7 of a mile? How many volunteers would that actually be for B? Okay, someone whispered to me 7. Okay, some are affirming. How did you guys get that?
We divided by 7 and then take that and divide 2 by that.
Okay, what does 2/7 give me in the calculator?
0.285.
And then you're timesing that by what?
I'm not, well,
Okay. So here's maybe why this one might be a little bit more easy than like A. Because look at the equation that we already set up to find our length. Right, like we have 2 divided by the number of volunteers. Look at how this answer is set up. It has 2 in the numerator. So the number of volunteers must be 7, right? If it's 2/7 and that's already a reduced fraction and that's giving me the length, then there might be 7 volunteers. And there is 7 volunteers. Did anyone do any other math for that or? Kristen? Okay. Table 5, did we get for when it's like 0.4 miles? Yeah. How many volunteers? 5, and how did you do that?
So there's 2 miles long. And then you divide 2 miles by 0.4.
Okay, 2 divided by 0.4 in my calculator is 5. However, and that is the right answer. So, but the way that I'm writing this, don't confuse it with this over here. It did give us the right answer, but it's 2 divided by my length or number of people. 5.
like,
So 2 over my length, and it's giving me what variable should go over here?
and
N. So see if that works for this one too, right? 2 divided by 2/7, which I'm not sure if you can do that in your calculator. You try. I recommend putting fractions in parentheses if you do that. But 2 divided by 2/7 is 7. Now, the rest should be easier. So if you're gonna get that far, like do it real quick. Now we've created a equation that'll help us. Table 7, what about when it's 0.125 miles? How many volunteers are there? 16, anyone disagree with that? All right, so let's see if our equation still works. If I do 2 divided by the length, 0.125, everyone try that in your calculator. I can even do it on my phone calculator, that's what I'm doing. See if it gives you 16, so it's working so far, it's not giving me answers that are weird. And then table 8, what about when it's 6/45, how many volunteers are there?
So that's what we got, but we know it doesn't make sense, right? So in that case, let's try that math. So 2 over, and I'll use the fraction form because that's what they gave us. Although they could, you could put it in as a decimal. But I'll show you, because fractions are something that comes up a lot, but we shouldn't avoid them just because we don't like them. All right. If I'm putting it in fraction form, I could use the slash to give me like a fraction bar. 2 is on top. And then 6 divided by 45. Usually I recommend you put fractions in parentheses like that, so that your calculator reads it right. And it gives you 15 actually. Okay, so it should be 15 volunteers for that. So you don't have to struggle with fractions anymore. You just have to know how to put it in your calculator and then see that your answer makes sense. Questions on that? Okay, so that's 15 volunteers for when it's 6 over 45 miles, 15. Now for the equation part, think of the math that we had to do. Each time we were dividing 2 by what? The length, and that was giving us n, and that worked consistently. So that is going to be our equation. And note it says write an equation that makes it easy to find the number of volunteers n. Now, this used to drive me crazy in high school when they made us do that, rearrange equations. Because I would just be like, well, why can't I just plug in the length over here? So like 0.4 into the equation we already made, and then solve for n. And although it works, if I do that, it just takes way more steps. But I'll show you that briefly. Because I first have to now break up this fraction. The only way to break up a fraction is to times it by its denominator. So I'm going to times each side by n. On the left side, I have 0.4n. On the right side, I have 2. I want to get the n alone. What's opposite of multiplying by 0.4? Dividing by 0.4. And whatever you do on one side of the equal sign, you do to the other side. And then I put that in my calculator, 2 divided by 0.4, and that gives me 5 volunteers. But look at how many steps I did. 2 steps really. Whereas if you just made an equation like this, you're just typing one thing into your calculator, just one step. So when it says makes it easier, it wants what you're actually solving for alone. All right, questions on that? All right, so then let's try another one. Or it's more on lesson 9 now, which is the same. Let's solve an equation for one of the variables. All right, so there is this equation, and what it represents, like, you don't really need to know in depth. All right, but you're given this equation and it relates the number of vertices, faces, and edges in a platonic solid. I don't know what a platonic solid is, but it doesn't matter. You don't need to know that. You just need to know this is the equation that represents that. This is what each variable represents. Vertices, faces, and edges. What you're going to try now is to write an equation that makes it easier to find the number of vertices. So what does this problem want you to do to the given equation? When it says makes it easier to find the number of vertices, what do they want? They want you to find the v, and when they say it makes it easier, they want that v to be technically, yes, but give me more. When it says we want it to be easier, we want that V to be not gone. I will show you over here again. So over here, it would be easier to find the base length. So over here, it'd be easier to find the area. In the problems that we just did, in number 2, that makes it easier to find the length that everyone had to clean. In number 4, this made it easier to find the number of volunteers. So when it says make an equation that makes it easier to find the number of vertices, they want the V to be by itself. Okay, so now you have to think, what math can I do to get it by itself? You can. All right, I'll kind of help you a little bit. I know this is hard. So in the first example, an octahedron, which I don't really know what that is, I'm sure it has 8 faces like it says, has 8 faces. Where in this equation would I put the 8? In the F, right? So let's see, I have V plus 8. Usually, anytime you plug stuff in, use parentheses. I know it doesn't always make a difference, but it's good to have it. So I plugged in the 8. And then the goal is to get the V alone, right? It wants you to make an equation to make it easier to find just the V. So over here, I could do some math. What's 8 minus 2?
4, 6.
It is 6. 8 minus 2 is 6. And then the V is not alone, right? What could I do to get it alone? I could subtract the 6, right? Think what I can do to make it cancel. And it's a rule that whatever you do on one side of the equal sign. Now, if I knew how many edges there were, then I could tell you like what my final answer is, but I don't. I can't just make up a number and guess. So I'm basically just have to rewrite it. And this is now an equation that makes it easier to solve for the vertices. Does that make sense? Kind of. We'll try the next one completely on your own. And I don't even know how to say that word, but it has 30 edges. All right, I have these. Make an equation that makes it easier to find the number of vertices. Okay, table 9. Can you tell me if, so it provides me the fact that it has 30 edges, what do I do with that number?
Plug it into E.
Plug it into the E. All right, this is my given equation. I'm plugging it in for the E. And then it wants me to make it easier to find the number of vertices. So I still need to get the V alone. There's multiple things next to it. They're different terms though. And I don't know, do one at a time. I always say start with what's farther. Sometimes it makes a difference, sometimes it doesn't. But if you always start with what's farther, you'll always be like in the clear. So what's farther from the V, the F or the 2? How can I make the 2 cancel? And whatever you do on one side of the equal sign. All right, combine like terms, what's 30 plus 2?
32.
And then is the V alone?
No.
So we're not done. How can I get rid of the plus F? And whatever you do on one side. And then I get that V equals 32 minus F. Am I all finished now? Yes. There you go. Questions on that? So it's just like if it was all numbers and you were isolating a variable. The only thing is I can't simplify this anymore because I don't actually know what F is. So that's all it can be. Questions on that? Okay. For time purposes, I'm going to skip down to is last one where it says less than 10%. Or maybe it doesn't on your paper, I don't know. But over here. Suppose you are organizing a party and have a budget of $B for the appetizers. You plan to order B vegetarian spring rolls at 0.75 each and S shrimp rolls at 0.95 each. The equation shown there represents this constraint. When might it be most handy to use each of these equations in your party plan? All right, so I'm not asking you to solve anything. I'm just asking you when it might be most handy to use each of these equations in your party plan. So for example, in the first one, which variable would you say is most easy to solve? Variable. B. And why? Why is B easier to solve for in the first one? Because it's alone. And what does B represent? Specifically,
Budget.
the budget. So if I am using this equation, it would be most handy to use this equation when I'm determining something related to my budget, determining if I am in budget or whatever. Do the same with the next two. Decide which variable is it easiest to solve for. And then what it represents, when might it be most handy to use each of these equations in your party plan? So in the party planning, when might it be most handy to use the second equation? So solving for number of spring rolls to buy. Wait, not spring rolls. Vegetarian spring rolls. Right, because V was for number of vegetarian spring rolls. When might it be most handy to use the last equation? Solving for the number of shrimp rolls. Right, because if you have the values of the other two things, then really you're just putting one thing into your calculator all at once versus doing all these separate steps. All right, definitely do all your practices. I know like it adds up. I went and shortened them all. So this is technically 2 separate practices, but it's like 8 questions total. It's not bad at all. And I only picked questions that I think were really important to the lesson. So if you have questions, you need to make sure that you're asking. There is a quiz Monday over everything we covered this week. So make sure your notes are up to date. You can use your notes on the quiz. All that stuff.